I'm Lily Higham.
And I'm Gordon Johnstone. Welcome to the Last Question podcast, a production of DataFest, the ongoing series of data and artificial intelligence innovation events run by the Data Lab, Scotland's innovation centre for data and AI hosted by the University of Edinburgh.
We're delighted to be joined today by one of our favourite authors, Adrian Tchaikovsky. Adrian won the 2016 Arthur C. Clarke Award for his incredible novel, Children of Time, and has garnered dozens of international awards and nominations for his works, Children of Ruin, Cage of Souls, Doors of Eden, and many more.
We're really so pleased to have Adrian join us today, and this is probably going to be part one of two, because our conversation with him was so interesting. I think we both read Children of Time around the same time during the 2020 lockdowns, where we would send each other books that we were enjoying. I think it was also around the same time that we read Cixin Liu's Dark Forest trilogy and Seven Eves by Neil Stevenson. So we're very much in the mood for this kind of millennia-spanning adventure.
It's also nice to be in the minds of some other non-human creatures for a while. I was kind of getting a bit sick of being stuck in my own human brain.
Exactly, being a human during the pandemic didn't feel particularly great. So something that we're going to be discussing a lot in today's episode is unconventional computing. And for anybody not familiar with the term, unconventional computing is basically just a process of computation through something other than standard digital computers. This could include old-fashioned mechanical computing, or cutting-edge quantum computing, or even computing through chemical reactions and biological processes.
This will be part one of our discussion, and we're going to talk about that unconventional computing, including things like biological computing and artificial intelligence in its different forms.
In Children of Time, the spiders utilised the brute force of ants to develop a society based on unconventional computing, and they harness billions of them to simulate the processing power of a computer. Do you think that biological computing will play a significant part in humanity's future?
I mean, I guess if I was putting money on it, I would probably say no, because we don't tend to think like that. But recently, it's been interesting to watch people be more open to biotech solutions. Most notably the one that I've had sent to me on Twitter about 5,000 times so far, for obvious reasons, is this using a dead spider as a grasping tool, because you can still utilize its kind of pneumatic exoskeleton, and it's very efficient. And this is one of the things that, because biology has had a long time trying to sort of hit and miss finding solutions to problems, you can get a lot of very efficient things from nature beyond what we've already got. I mean, the big one I'm kind of waiting for is utilizing something like spider silk to make a material with sufficient tensile strength for a space elevator. Because if we're going to do space, we can't just do it by sending rockets up and down. No matter the current private enterprise and that thing, that's not the answer, because it's colossally inefficient. If you can get a space elevator working, and there's, the math says there's no reason you can't, as long as you've got the material strength. And I appreciate this is not computing we're talking about, but it's the ethos behind what might lead to biological computing. That it is vastly more efficient. And I think this is the one thing that any kind of biotech solution can offer, is it's frequently far more efficient than just doing things our own brute force way of making everything from scratch. So I suspect there probably is a potential timeline from now that would lead to us using some manner of biological computing. I don't think it would be ants, which is a bit of a shame, but if we're ever going to have actual sort of AI or anything like that, I wonder if that would be the way to do it, is having an actual biological computing framework to host it on, because I'm not convinced our own computers are ever going to get quite that complex, and B, because the way that biology organized itself was probably more conducive to something like a biological intelligence, which is what we're aiming for. But I think it would take a big a big shift in the way people are willing to countenance technology working, not least because the big fear I think about biotech solutions, especially for something as complex as computing, is do you have the same control over them? Although these days, frankly, neural net AIs and purely mechanical computing is sufficiently complex, I don't think we have the same control over them either.
Yeah, we don't know what's happening in those middle nodes.
There was that recent business with the engineer who thought who was concerned the chatbot had become sentient, and that kind of all blew up. But the root problem behind that is the computers are sufficiently complicated that we don't know what they're doing, and therefore it is impossible to say for absolute certainty, no, this is just doing its thing.
It's like the multivac in the last question. It gets to the point where nobody understands how it works. You just kind of rely on it.
It's interesting about the efficiency of biology as well. I think I was reading recently about how the brain operates on something like the amount of energy that one light bulb does compared to a computer, which takes a lot more energy, but it can do maybe even more computing processes at the same time. So in that way, even just for energy efficiency, to be able to power something that can make enough computations that we need, might have to end up going back to the biological energy efficiency.
Yeah, although I think the problem with that kind of comparison is that the computers, all the computers that we have, do not really work like the brain does. Computers are very good at being computers, and the brain is very good at being a brain, but they're not actually the same thing. We cannot compute as fast as a computer. And it always fascinates me that the word computer predates the things computers, because it was originally a job that a person had to compute. And obviously the reason no one does that anymore is because computers are much, much better at it. But a computer's computation is not like a brain's braining. And so it's very difficult to draw those comparisons. There was an XKCD essay about at what point in history did the total computing power available to mankind sort of surpass a human brain, or possibly it might even have been surpass all the human brains. And it's one of those, well, it depends how you look at it. And if you look at it this way, then it was quite early on. And if you look at it that way, it hasn't happened and probably never will.
And it is a lot like what we were discussing earlier on. The Arthur C. Clarke quote, "Any sufficiently advanced technology is indistinguishable from magic." We heard somebody else say, any sufficiently advanced technology is indistinguishable from nature. Nature tends to be really quite efficient when it comes to these things.
Yeah. Well, again, it's yes and no, because yes, as long as it's doing the specific thing it's evolved for, I guess. But the thing you can do with a computer, and the thing that the Portiers do with the ants in Children of Time, is you find a way that you can then effectively customize what it does on the fly. You can reprogram it to do different tasks. You can program it to be flexible and do tasks as and when they appear, which is something that nature frequently isn't terribly good at. And again, it's a very apples to oranges thing. There's this very, very persuasive idea that yes, a computer is an artificial brain, which has been, I suspect, has been around since as long as there have been computers. It kind of fundamentally misunderstands what a computer is and what a brain is, because there is a bit of overlap, and as we've made them more complicated, that area of overlap has grown larger, but not a lot larger. Still, most of the things that computers do are not what brains do, and not what nature does. This is going back to the zombie spider kind of gacha claw thing. That's the interesting thing, is people are now at least looking at nature for solutions to engineering problems, and that's I would imagine. One of the things, if we let's say we were to look at ants, one of the things, another recent article I've been sent, but also something I've personally been writing about for quite a while, is an ant's nest and a brain work in very similar ways. The way that our neurons sort of come to consensus and give us decisions is very much the way that an ant's nest comes to a decision based on the individual inputs of its members. And so I think if we're ever going to have that big singularity step up, biological computing would probably be the path to it. Which terrifyingly probably means that there's some tech billionaire who's doing it right now and we just don't know about it, I guess.
That's always my concern about any single technology, is that there's an Elon Musk character out there just waiting to end the world in some new and imaginative way.
Maybe it will start with something like his neural lace. I don't know how that's going, but start off with something which is a hybrid, so some human-computer interface, brain-computer interface, where it will be a hybrid between both rather than just like, here is a human mind uploaded onto a computer. Go.
Well, that's so... Yeah, I mean, I'm aware this is one of the big interesting areas of science where there are scientists who will tell you this can never be a thing. It is literally impossible. And others will tell you, yes, we'll do it in about 5 years. And it's the thing I've written about I've basically taken a variety of standpoints in my work from this is the thing that, I've actually recently delivered a manuscript where one of the things that is mentioned is, yes, in our quest for kind of immortality, we uploaded minds, but they just weren't us enough. Which is, I think, probably one of the things you might well get. You could probably end up programming an algorithm in that chatbot style to sound very, very much like you. And at what point do you decide this is me? I have uploaded my mind onto a computer, rather than it just being an algorithm that has looked at all of your social media and is very good at mimicking the way that you come across. And we're at that point. You could absolutely get it. If someone has a large enough sort of footprint on the internet, you could absolutely train an algorithm to sound exactly like them and quite possibly predict what they would say in any given situation. And again, I'm absolutely sure someone is doing this at the moment. It would be very useful for a variety of world figures to know exactly how they're likely to react on Twitter to any given thing. But it doesn't make it them. It is very much it's a mask is my kind of image for that kind of thing. And I think this is all you get, and the masks will get better and better. But just like the chatbot and the engineer, you say, well, at what point do you decide that this is you? Because of course, the one thing that you need to know if it is you is to be that thing and experience it. And it will swear blind that it is you because that's what it's programmed to do. So I think that's the big problem with Uplift. Not Uplift, with uploading a mind onto a computer is we will never be sure if we've done it, because we are very good at making computers. We are extremely good at making computers to fool us into thinking that they are people. That's, the reason that the computer operating system that Verona Kern uses is ELIZA. That's the call, the callback to that famous case, which has a very simple computer algorithm that is absolutely convincing to a lot of people that they are talking to a real person, which shows you that the Turing test is vastly out of date as a diagnostic tool, because we bridge the gap, we do the work to make that thing a person in our heads. But in Children of Time, I have all right. So Children of Time is probably my most complex look at this particular question. And so you have Avrana Kern, and for people who haven't read the book, this is someone who links herself to a computer in order to survive basically a long sort of period of hibernation, and then ends up kind of with no hard line as to where her cognition ends and the computer begins, and then is effectively uploaded onto a variety of different media, including the aforementioned ants, which are being used as a computing substrate by the non-human entities in Children of Time. And there is a lot of discussion throughout the books as to precisely what there is of her and how much there is of her and how much of the original person is there. And one of the things I think it's mentioned in Children of Ruin, it certainly comes up in the new one, Children of Memory, is the idea that she is absolutely convinced that she is Avrana Kern right up until the point where she has to access something that Avrana Kern would know, and she doesn't know it. So she, in a very computery way, she doesn't know what she doesn't know. She basically is just part of her programming is the certainty of her own identity, which came with her because Veronica was an extremely strong-willed person. But she's forced to concede that actually she's probably not Veronica when she starts looking at the fine detail. So you're left with a personality, and you can tell from our meeting of the original human at the very beginning of Children of Time that it is obviously based on the original fairly acerbic personality of Veronica, but based on is kind of what you get. On the other hand, I mean, having said all that fairly negative stuff, that may yet be enough. I mean, at the end of the day, if a very, very advanced computer program based on me could kind of go on into the future, I'd take that. That would be a good legacy. I don't think it would be me. I mean, one of the other very common sci-fi tropes with this is the idea that there is a moment when the you that you are leaves your kind of the glob of greasy gray matter in your head, and you are inside the computer now, and you have to, and that's not going to happen. It is entirely possible that we have no idea if it's ever going to be possible for there to be an actual consciousness inside a computer. And like, as going back to the previous question, a biotech computer is probably a better bet for that, because it is more complex and because it's organized in a way that we know can generate our own sense of consciousness. But it won't be the same consciousness, even if it has the same memories and believes it's the same entity. The you that was in your head remains in your head. And of course, the other idea is in a lot of the cases that we see in fiction, and I think there's even a TV show Upload, which is on at the moment, which is to do with this. You have to destroy the original to create the copy. And while that is narratively convenient, I don't think it's necessarily a thing that's going to be the case in real life if we ever try it. Mm-hmm. Which leads to another possibility I've written about, which is the idea that vastly powerful people just creating enormous armies of themselves. Because why stop at one? Why not have an entire civilization that is all you? Because I can think of a lot of people in the world that would be delighted with that idea.
Yeah, it depends how the creation of the copy would be made, I suppose. If you're doing it with kind of from a functional viewpoint of looking at inputs and outputs and analysing the outputs to work out what a future copy would do as a system, then you could just copy it non-destructively. But if you're going to go fine-grained into kind of the inner workings of the system in the brain, then all the scanning technology we would have to be able to look at perhaps like placements of neurons and how those are in a network in your brain would involve some kind of destructive scanning technique, as we know so far.
Well, my take on that one is most of the brain activity that goes on is very close to the surface. My understanding at least is, and I'm happy to be corrected on this, that the core of the brain doesn't do that much. It's the effect of the crenulated surface that is where most of it takes place. And our ability to read the activity of that has come on in incredible leaps and bounds in just the last decade. And our ability to actually implant sort of technology to read that has also come along enormously. I mean, the fine level of things we can make to read individual neurons and stuff like that is now, mind-blowingly good compared to what we had just a few years ago. I suspect, and the other, paired with this, what is it that is in us at any given time? And my personal feeling on this is it's not the physical brain. It is the ongoing electronic transmission process. It's the state. It's the state of the neurons. It's not the physicality of the neurons that generates an us. Because if it was just the physicality of the neurons, you could bring people back from the dead, if nothing else. But the fact is that when that state winks out, you cannot bring it back.
The patterns matter.
Yeah, the patterns are us. we are the current state of pattern of neuron firing in our brain at any given moment, which makes us feel terrifyingly ephemeral. So in that case, having your kind of your mesh reading the activity in the neurons is going to give you a you that you can transfer. I mean, if you link yourself with your sufficiently complicated computer and it mimics your state, and you'd say, you stay linked to it for whatever the sufficient period of time is, and it's mimicking your state, then eventually, presumably, you have pulled the ripcord on that computer hard enough that it will keep going. I mean, the other thing, something I do in Children of Ruin is this quite an old idea of what if you had something in between the two halves of the brain that passed information received backwards and forwards, because we have quite a narrow connection between the two halves of the brain. In some rare surgical procedures, it can even be severed to separate those two halves. It's a drastic cure for certain types of severe epilepsy, I believe. And in those cases, the two halves of the brain will just get on with things, and people learn to adjust for the fact that there is no communication between them. But you could have a thing between those halves which communicated everything backwards and forwards, and then you could have that thing start to insert. You learn the patterns and start to insert its own inputs backwards and forwards, and effectively your left half of the brain would believe they came from the right half, and so forth and so on. It is in a variety of ways a thought experiment, but if that thing in the middle was connected to a sufficiently complex computer, it could learn an awful lot about what your brain was doing and replicate that and become another you in that way. So I think there are. I mean, genuinely, I think that non-destructive ways of looking at this are probably considerably more likely to bear fruit than just kind of sectioning the brain as finely as possible and rebuilding it in a virtual sort of environment.
Yeah, I suppose it's like you said before. Actually, it depends what it's going to be used for. If you don't need something so fine-grained that you need to see every neuron and how it acts over time, and you can do it by reading patterns with the kind of like methods we have with different probes put in the brain, or reading EEGs, if that's enough for some uses, then we'd probably do that instead. Maybe like the example you mentioned earlier of being able to predict your own behavior in different situations.
I mean, I suspect people are going to be always more interested in predicting other people's behavior, but I mean, I don't think you need their brain for that. I think that, like I say, if someone has a big enough internet footprint, you can do it from that without ever needing to get involved in their brain at all, because, and again, I'm sure this is being done, and it's at a variety of levels, from advertising and marketing to counterterrorism. But if you look at someone's activity online, these days we're also plugged in. A large number of people, you could quite readily predict how they would react to any given situation, in the same way as you could probably predict how any given demographic will react in majority to any given situation.
Yeah,
and this is very, very far from kind of brain upload, and it's also, I suspect, far more real than brain upload currently is.
We spoke to a technology ethicist in a previous episode called Stephanie Hare, and this came up because she was advocating a sort of dead man's switch, so that as soon as you die, every trace of you online is deleted by some, magical process to prevent anybody from copying you against your will, after your death. I think that's quite a good idea.
I mean, yeah, that sounds like a God. That is the weird kind of post-mortem electronic suicide. I can certainly see the point of that, although at the same time, the idea of actually leaving, I've always been very invested in the idea of leaving something behind. So it is quite drastic from that situation. I'm going to throw a book at you, not one of mine. Do you know? You will absolutely know Cory Doctorow as a writer, given your interests. Do you know Walk Away? That has probably one of the most nuanced approaches to upload, in that so upload technology is a possibility and walk away, but the uploaded personality cannot deal with the complexity and difference of its situation and goes mad very quickly. So what they do is the uploaded personality, they basically upload they make it basically effectively a coarser and coarser copy until what they have got is simple enough that it can abide by its own existence and get to grips with what it is, and then they slowly bootstrap it back up towards full complexity. And I thought that was an extremely clever way of looking at it.
Yeah, I like that idea. I wish someone had done that to me. Or maybe they are doing that to me.
What I mean, one last word on the idea of uploaded intelligence is there's another branch of science which actually militates quite strongly against it ever working in a way that we imagine, which is we are becoming more and more aware that more and more of our cognition is driven by stuff that is not in the brain. Even down to things like the gut microbiome and the hormonal system, all that stuff that we used to think was just kind of sloshing about getting in the way of our Spock-like logical supremacy. That's all us. And quite possibly, if you copy the brain, you might get a computer in a way, because so much of the stuff that is us is that emotional system that we have kind of tried to discount as irrational and irrelevant and so forth. But it's us. And if you copied the brain without the body and without those inputs, I don't know how much of us you would actually get at the end of the day.
Yeah, some of what we could still call information processing is happening outside of the brain. Yeah.
Yeah, we are, you are what you eat in a very real kind of way. We are our livers, we are our guts, we are all manner of these systems. Because of course, I mean, that's the other thing about biological systems is they don't evolve necessarily terribly efficiently in a very compartmentalized and logical way. Any kind of biological system, from a cell to an organism to an ecosystem, is a large number of things developing in a community, whether it's an antagonistic or a cooperative community, over a very long period of time. And therefore, every bit has evolved to take into account all the other bits.
We're evolving ecosystems, not evolving individuals. It also sounds like we're getting to a further point in science where it's even more breaking down of dualism. A lot of us realize that it's not like soul and body, and now we're working out more that's not even brain and body. Yeah. Which I think for a long time that was a very seductive idea that you could free us from infirmity and weakness by kind of separating the brain from the body, and you have all the brain in the jar, and they saved Hitler's brain. And even the Martians in War of the Worlds are very much built on the idea they are just brains, and the tripods and the other machines they have, although they make bodies at their convenience. And that's even though they are the monstrous bad guys, that is still kind of the intellectual dream. And that is also where a lot of the brain upload sort of fiction goes, is the idea, well, once you've got the brain, you can be anything. You can be a spaceship, you can be a robot on Mars, you can be all of these things you can be if you can free the brain from the body. But you are kind of then freeing whatever is the brain from the thing that is also you. You do see in Children of Time as well the kind of the way Avrana Kern's mind changes over time.
And like I say, I mean, there's quite a lot of sort of philosophical stuff thrown at that idea in the new book, Children of Memory, as well. It's one of the major strands in it. Especially because I have to think through how I'm going to say this without massively spoilering the second book. There is a particular type of intelligence that turns up in the second book, which is very, very non-human and very, very sort of problematic for all the other characters. And a lot of Children of Memory is from the point of view of that, and precisely how that stands in relation to humans and more traditional biological intelligence. So, I mean, a big part of Children of Memory is just an examination of what intelligence is and what it is, what it is to try and be human when you're not.
I'm intrigued to work out how you're going to do that, because it really does seem like a difficult point of view to write?
Well, I mean, this is the series in which I try and do difficult things.
Good.
This actually brings on to another thing that we were going to ask. Obviously, a lot of your books feature non-human protagonists, and it must take a completely different approach to writing those characters and still making them, relatable and approachable to an audience. Whether it's the spiders in Children of Time or the cephalopods in Children of Ruin. Do you take a different approach to writing those characters, even though they span like many, many generations, or do you sort of treat them as, for lack of a better word, humans and then people, and then work backwards?
Yeah, I mean, I guess, they're people, but they're not human, I guess, is the first thing that informs the way I approach them. Though I build them from the ground up, based on my understanding of the actual natural history of the species I'm dealing with, or if I'm creating something genuinely alien, just working logically from first principles. I mean, there's a very, very good book called Evolving the Alien by Cohen and Stewart, which is kind of a, it's also, I think it's also called What Would an Extraterrestrial Look Like, depending on what edition you get. But it is an extremely good book for how to think when designing alien species. And just looking, what things are likely to happen, what things are unlikely to happen, what is a repeated pattern in evolution on Earth that you could probably expect an alien to also do. Like, if there is light, it can probably see because eyes have evolved many, many times, and photoreactive chemicals are a very common thing. Whereas there are other things you can find another thing. Well, this only happened the once, so if you reran evolution, you probably wouldn't get this thing. And that kind of thought is really useful. And then, because obviously my main focus of interest is often sort of what the sentience is like and what it's the civilization and sociology and so forth. It's a logical sort of grassroots upwards process. You think, well, if it's coming from this and these are the things that are driving it, how does that express itself when it has more of a conscious understanding of its world? What is it likely to believe? What are its social structures going to be? And obviously you're never doing this in a vacuum, and so obviously you've got things like the spider gender politics form this weird kind of mirror of human gender politics and things like that. The octopuses are a lot more difficult because there's this weird thing about octopuses that they, even at their most social, they kind of hate each other most of the time. And
that's relatable.
Yeah. But building that into a civilization is really hard. So it was a lot of fun, just kind of, because obviously to a certain extent you have an end result and you have to kind of do this sort of post facto building it. Well, I need them to have a civilization. So how is that going to come about? Mm-hmm. And they're another, it's not quite the same focus, but they're another species in Children of Memory, which gets the same kind of treatment in it and has a very different way of development and advantage and limitations. And I'm looking there with particular. Neurodivergence is the thing I'm looking at, I guess, in that in particular, and the idea that rather than being the problem that a lot of people like to characterize it as, actually maybe neurodivergence is a super useful thing in a lot of situations. So
it's really interesting. One of my favorite characters in your books is Kit, the crab-like character, who sells advertising space on his outer shell. I really enjoyed that because we really can't be too far away from that in human society.
Yeah, well, the Hanny Lambert are interesting because you don't ever get Kit's point of view, and so you have to kind of try and work out what's going on based on human assumptions, which are not terribly accurate. And it's one of those things. I've just actually finished doing an editing pass on the third book in that series, and there's quite a lot of Kit stuff still going on, and you get a bit more of an insight, especially with his relationship with the human crew of the Vulture God, and you get a few more bits where he's very much front and center doing his thing.
The idea of uplifting animals to comparative human intelligence is a popular trope in sci-fi, from the island of Dr. Moreau to David Brin's Uplift universe to Rocket from Guardians of the Galaxy. But it seems to be a very anthropocentric view of what intelligence is and can be. In other words, uplifting seems to imply that gaining human-level intelligence is desirable and a progression from animal intelligence, a progression. However, in your novels Children of Time and Children of Ruin, the uplifted animals take on quite different forms of intelligence, and it sounds like in Children of Memory this will happen too. Do you think we need to be more open about what we recognize as intelligence and also what kinds of intelligence we value? I think even just the start with that you're writing such different intelligences means that you probably have a very open mind to begin with of what intelligence is.
Yeah, I mean, I tend, so my basic model is obviously one of the things I've had to grapple with quite a lot in a variety of different books is, well, how am I going to put over an intelligence that is not a human intelligence? And also, obviously, how am I going to have human characters interact with something that is not a human intelligence? And I tend to work with a model which is, it starts with commonality, because at the very basic, there are a series, certainly when you're dealing with anything else from Earth, and this is quite possibly something that would be common to to an alien species, is at the very early ends of evolution, you are dealing with very common things. You are going to need to develop certain common things. So you are going to want to make more of yourself, otherwise you will die out. You are going to want to survive, therefore, to do that. You are going to want to avoid things that will impair your survival. So hunger, fear, there are going to be certain basic things that are innate in a toolkit from a very, very early point. I am unapologetically sort of, waving the flag for animal intelligence. And across the last 10 years, there's been an absolute explosion of behavioral research showing that intelligence, as we can kind of recognize it, exists in far, far simpler things than we ever thought was possible. Case in point, the portia spiders. The spiders that Children of Time uses and sort of advances to a full-on technological civilization, all of that is based on real-world research by, amongst others, Dr. Fiona Cross, where we have discovered, yes, these tiny spiders with this pinpoint-sized cluster of neurons for a brain are capable of very, very sophisticated decision-making, object permanence, planning, all of this stuff that is very hard to account for if you just say, well, obviously it's just, it's pre-programmed instinct and they're just little robots going about the thing, because they are, even with that tiny sort of cerebral toolkit, capable of very, very complicated reactive behavior. And we're discovering an awful lot of other, it's at all kind of levels of the animal kingdom. And, to a certain extent beyond that, even things like, the bizarrely complex behaviors of slime molds and things like that. Intelligence is not the sole province of humanity. Intelligence is a thing that exists on a spectrum and starts much, much earlier than anyone ever really thought. And now we are I think there's been a shift of philosophy that allows behavioral scientists to look at animals in that way, rather than just kind of assuming, well, you've got to assume they're robots, barring very, very hard evidence otherwise, because otherwise it's anthropomorphization, which is very much the philosophy that was being taught to me when I was doing psychology in the early 90s. We've kind of moved on from that, and thank God for that. You start with that very common toolkit at one end, and you diverge, because obviously every creature has its own environment and its own needs and its own particular life cycle and whatever. And playing where that's kind of the interesting bit to write about is, all right, so let's say you have there's something I've not done yet and will probably do at some point. What if you have a creature with a full-on metamorphosis where it's sentient in one stage of that? So, let's say you have a society of hyper-evolved caterpillars, but the butterflies are completely insensate and only really exist to mate. What's their attitude to that? How does that become part of their culture? The fact that as part of your just the way things are expected to go, you are going to cease to be you at some point in order to carry on the species.
Oh, there'd be so many interesting things to explore there.
Exactly. I mean, and honestly, nature is full of that sort of thing. There are so many, even honestly, even things much closer to us than a caterpillar or a butterfly. Things are very, very different. We have, I mean, obviously, they're the huge handbag clutching thing going on about trans people at the moment. Nature is full of that. That's just a natural thing. There are so many species where gender is entirely fluid and individuals shift from one thing to another. And what would it be like if that was just a more accepted thing? Can we maybe just imagine that in our science fiction? That would be fun, wouldn't it? You get this grand divergence over evolution, but at some point, if you are approaching, if you have a technological civilization, if you have a civilization that develops any kind of science, you start to converge, because even the most alien thing is sharing the universe with us. And the basic properties of the universe that we are at a level where we can examine to a reasonable level of certainty. So, how the electromagnetic spectrum works, which gives us, not just light and radiation. It gives us radio. Radio is kind of the radio frequencies. They're not a human invention. That is how the universe works, that we are utilizing to communicate. Binary. The basic level of information where something is there or it is not. That's quite possibly something that many different sort of aliens might end up using, because it is the most efficient way that we have found, at least, of encoding information and passing on information. The universe works in a certain way. At some point, if we meet an advanced alien species, especially if they come to us, because by definition at this point, if any alien comes to us, they are more advanced than we are, or they've gone a very weird path into getting into space. I mean, it's theoretically possible that you could have a species that just ends up in space through purely biological means and is just that kind of, planet-devouring locust swarm or something like that. But it's the evolutionary logic for it is really weird, because I could, if I wanted to, I could almost certainly put together a scenario where that would be the case. But most logically, if something turns up at our doorstep, it's more advanced than us. It has a grasp of the universe that is the same universe that we have a grasp of. And so you get this convergence towards, no matter how alien they are, theoretically, we could start to communicate with them through expressing the constants of the universe, through talking about the hydrogen atom. I think it's the frequency of the hydrogen atom that is the one that we think of as the most likely that any alien species would use to communicate on. I'm mangling the science of this, but that's because that is, it has a significance that is universal. And one of the other, Paul, going back to Paul Cornell, one of the things he was talking about, actually, there is a reason why aliens might want to come to Earth, in that the size and distance of our moon gives us a perfect eclipse, and that is not actually in any way a universal. So this is one of the only places in the universe you could go and watch a proper eclipse. So quite possibly that is our tourist, our kind of tourist draw for alien species to come to Earth and spend their alien money.
We thought they'd come and save us from ourselves, but instead they're just taking photos.
Yeah, I mean, they don't need us there for the eclipse to work, of course. So they may be just waiting for us to wipe ourselves out so they can come and have their pristine tourist destination.
It's kind of like if you want to have a picnic, but there's like tons of ants or bees around. You think, I'll just wait for them to dissipate and then I'll go and have my nice time. The third book in the Children of Time series, Children of Memory, is coming out in November 2022. And, Lily and I cannot wait to read it. We've loved the other ones so much. It's a universe that neither of us ever get tired of inhabiting. So with that said, I think it might be time for some wild speculation.
This is the part of the show where we ask our guests to go beyond the scope of their research or expertise and engage in some wild speculation about their field. Adrian, what do you think the biggest advancements in artificial intelligence will be over the next 100 years?
Over the next how many 100 years?
100. We can change that number if you have more interesting things to say about 50 or 500 or 1,000.
It feels a bit like assuming we have another 100 years is wildly optimistic, without moving into any other centuries at all.
Change the section to wild optimism.
Honestly, I think it kind of gets to the point of I, for one, welcome our new AI overlords. One of the other big debates you get within amongst scientists and engineers is strong AI actually ever going to be a thing? And I think if it's going to be a thing, it feels like we'd probably get there in my lifetime even. And if it's not going to be a thing, then obviously it's not going to be a thing. It may well be that we will never make a machine that has that sort of that personhood, that consciousness. Although, see previous discussion about whether we'd actually know. But that, I think people are very worried about an AI would be this. In fact, we get constant warnings from vastly powerful tech billionaires that yes, this AI will be this vastly impersonal force that would heedlessly destroy all humanity under its kind of crushing boots and not care a damn about anything other than itself. There is a certain irony to the terms they tend to use to warn people about AIs, because it always seems to me that they are absolutely describing themselves. I think that there is a destructive kind of expert system that we need to be worried about, which is the thing that does its job too well. It's the paperclip machine that breaks down the world for paperclips in the most common iteration. That's not AI though. That's certainly not strong AI. I think the enormous development that might actually save people is a strong AI that solves our problems. We seem to be running into a hard limit to the human ability to solve human-generated problems. And it comes down to the way our political systems work. And it comes down to a set of tendencies of human neurology to be very easily fooled by certain things. We're very easily fooled by people who are very confident, despite the fact that confidence does not correlate with competence. We are very easily fooled by belief systems that promise us certainty. There's a certain answer rather than maybes and perhapses. These things would probably not apply to an AI. I think at some point we get to the point where actually an AI could solve our problems better than we will ever solve our problems, because it will not have our limitations in the way we think. If another book recommendation for you, there is a book which deals with an AI trying to do this and the problems it runs into. It's a novella. It's by Justina Robson, who's one of the great masters of writing about AI and non-human perspectives. It's called Paper Hearts, if I'm right. Let me just double check that for you. But it is a relatively recent. It is, yeah, Paper Hearts. It's relatively recent. It is one of the most insightful looks at this specific scenario, because we've kind of seen the far side of this scenario is Ian Banks. Basically, it's the culture. It's right. The AIs, they've kind of taken over, and they are just doing their best to make things as good as possible for as many people as possible. And it isn't perfect, but it is probably closer to perfect than most sci-fi settings ever get. Which is honestly why the plots of the culture books tend to deal with things happening at the edge of the culture or outside the culture, because everything in the culture is this kind of big ball of wonderfulness where nothing really happens. because things happening tend to be bad. But Paper Hearts is that transition. It's basically the AI telling humans, okay, this is how it's going to be. And humans saying, yeah, but that's all right. I told you to do this, but that's not exactly what I imagined. And it's brilliant. And it is honestly the only book I've actually read which really wrestles with this particular very common scenario in that transition moment. But that, I mean, honestly, I think if we're going to have a big development in AI in the next 100 years before everything butts us down to the next Stone Age, maybe that's it.
Mm-hmm. That's what I'm hoping for.
That's what I'm hoping for too. We hope to have Adrian join us at a DataFest event in the future.
So finally, on to the last question. Each episode, we pose our listeners a question and invite people from around the world to offer their thoughts. We'll read the most interesting ones out on the next episode. Our question this week is, do you see biology having a bigger role in computing in the future?
So that's it from us today. We'll be back next time with more insight, innovation, and wild speculation. Feel free to drop us an email to say hello or to suggest a topic or just to say hi or even to make corrections. You can email us at datafest@thedatalab.com or you can find us on Twitter @datafest_.
Thank you for listening. Join us again next time for another episode of The Last Question.